So, solving absolute value inequalities. I got it all typed up for you in this little gray box right here of what our strategy is. A lot of work on paper before we go to like the computer for homework. Again, we'll do every question today, work shown. This process I'll talk you through has to be done on all of them, and I'll come check last time's work while we're working on this one. But here's some fancy words that you don't see used in a normal math class, but they are on the ACT, a disjunction and a conjunction, right? We'll talk about them as we go through, but I think we're very down with the fact that we've got like greater than sign right here and a less than sign right here. I'm just going to dive in and swim. Here is the steps. First of all, we're going to have to realize that we might accidentally do our entire test wrong because you think everything on the test has absolute value bars around it. You have to buy into step 0. Does this problem have absolute value bars with it, yes or no? Because, dude, if it doesn't, we don't do this strategy. Does that make sense? This strategy only works if we got absolute value bars. So that's phase 1. Do we even have absolute value bars? Yes, we do. Then we go with this. Are the bars all by themselves? Just like they were the last time when they were equations. Are the bars all by themselves? Yes or no? Yes. And that's the secret. Because this symbol tells you what, this symbol tells you what to do. Is that symbol a less than or a greater than? I know it's got an equal to bar, right? But is it a less than or a greater than? Less than. Here is the magic phrase of the lesson. Disunion greater than ors. Made that phrase up because dis is short for a disjunction. Union literally means it's going to be a union. Greater than is the symbol that we are talking about, and ors is like the word or, you know, like and versus or. So here's my question. Disunion greater than or, is that a greater than symbol? Yes or no? No. So this will not be a disjunction. This will not be a union. It will not be an or statement. This will be a conjunction. So here's what we'll do. We will write a con above it. A conjunction, which is not a union, it will be an intersection. And this is going to be an and statement. I know this is really weird. We're starting off. It's going to get so much easier as we do more of them. But you check the symbol after the bars are by themselves. If it's a greater than symbol, it's going to be a disjunction, which will be a union, which will be an or statement. This was not a greater than symbol, so here is a conjunction, which is an intersection, and which is an and. So now, here's the move. Now that we figured that out, we take what's in the bars, right? And we're going to say plus 3. What you see is what you get. You will have a less than or equal to 2. Did you notice the bars have disappeared now, correct? So then we put a word. We have already decided that the word will be and. Then here's what we do. What's in the bars never changes. So you see y plus 3 was in the bars. Y plus 3 is still there, but here's what we do. We switch the symbol, switch the sign. So that symbol is a less than or equal to. It's going to become a greater than or equal to. This is a 2. We are going to put a negative 2. Just like I asked you when we started with, what value of x makes that true? You said any x's that are bigger than 3 or any x's that are less than negative 3. Are you with me on that? We took what's in the bars. We said it's got to be what you see, bigger than 3, or you take what's in the bars and make it switch the symbol, less than negative 3. That would be a true statement. But here, now we're on easy street. Can you solve both of those for y? Go for it. So we shall subtract 3. Symbol does not switch. And then we shall subtract 3. And that gives me a negative 5. Are we okay with those two pieces? We'll graph both of them as helper graphs. First, I need to put my smaller number on the left. Be careful. Who's smaller, negative 1 or negative 5? Yep, very good. So negative 5, negative 4, negative 3, negative 2, negative 1, 1, 2, 3. And I will do helper graphs. So y less than or equal to negative 1 is this blue graph. He's got a closed dot going this way. And then this green graph is going this way. And all of this junk was done to get down to the number line for our final answer. My question is, do I want the union of those two graphs or do I want the intersection? And we have already answered that before we got started. What do I want? the intersection. So we bring that intersection down to Chinatown, and we ignore everything else. Please make him fat so I can see him. We ignore everything else. All of that was just to get to there. Is that one statement? Sorry, my thing keeps growing. Is that one statement or is that two statements? How many pieces do you have on the puzzle right there on your graph? Is there one piece or two pieces? Right there. Is that one or two? That purple thing. That's one. That's why it's a conjunction. They merged into one, right? That's what conjunction means. It's like, okay, we're going to put them together, right? Conjunction. And doesn't that mean that y goes in the middle for our label? Symbols point to the left every time. -5 is our smaller boundary. -1 is our bigger boundary. And they had equal to bars on each one of those. I kind of wish I would have had the equal to bars in the blank, but I wrote too low. Are you okay with how I answered that? It's only one example. We got to do a few more to get better at this, right? So here's my question. Is this an absolute value inequality? Yes or no? Yes. Are the bars by themselves? Yes or no? Now here's the weird part. I'm going to memorize this phrase, disunion greater than or. What symbol is that? A greater than or a less than? So does disunion greater than or fit? Yes. So above that, you will put dis for disjunction. You will put a union symbol because it's a union, and you will put an or, right? This is a disjunction, which means the graph will be in pieces, right? It's a disjunction because we will unite some things together, and it's an or statement. So now let's take what's in the bars, and what you see is what you get. I see a greater than 6. I put a greater than 6. What's the word in the middle? Or. Never change what's in the bars. It's C minus 2. It's going to stay C minus 2. Switch the symbol. Switch the sign. It was a greater than. It becomes a less than. It was a 6. It becomes a -6. Cool? Let's solve both. Let's solve both. So adding 2. C greater than 8. Or C less than -4. Holy cow, I ain't going to make it. I got to go from -4 to 8. That's 12 spaces. I don't have 12 spaces. What would be better to count by than 1s? 2s would probably be okay. If we needed to count by 4s, we could count by 4s, you know what I mean? So -4, -2, 0, 2, 4, 6, 8, 10, 12. Finish them out. But we might not make it counting by 1s. So C is greater than 8. Helper graph. Open dot, going to the right. C is less than -4. Open dot, going to the left. And we have already decided what we want to do with this before we got started. Should I take the union or the intersection of those? Union. So that comes down to Chinatown. And now, let's read our graph. The graph tells you what the answer is. I'm going to cover that up. How many pieces? One piece or two piece? Disjunction, right? Two pieces, right? So I have two things in the answer. What does this first piece say? X is what to -4? Less than or greater than? Less than -4. What's the word that needs to go in between them? Or. X is greater than 8. Are you cool with the two different pieces there? It's only two examples, right? But you did all of that work to get to your final graph. So let's try again. Stage 0. Is this absolute value? Because, man, if you do this on every question on the test, that is danger zone. Is this absolute value? Yes or no? Yes. Are the bars by themselves? Nope. What's my first move? I would like to get rid of this -8, so guess what I need to do? Add 8. And back when we did equations, a lot of people didn't want to write this down. You better write it down. You better keep the bars there. We got to get the bars by themselves. So I added 8 to both sides. Are we okay with that move? I think up to here, we're golden. It's this new step of how do I know what to do here? You can't do disunion greater than ors until you get the bars by themselves. So you have to do it on this one. What is that symbol? Less than or greater than? So does disunion greater than or fit? It is a less than. So it is the opposite of all of those things. What we'll learn is the opposite of a disjunction is a conjunction. So we'll do con. Opposite of an intersection is, opposite of a union is an intersection, and the opposite of or is and. So I don't come up with the second phrase of con, intersection, less than and. I just remember disunion greater than or, and if it doesn't work, it's the opposite of a disjunction, it's the opposite of a union, it's the opposite of an or. Are you cool with all that? So, all right, let's see if we can set up two inequalities. Take what's in the bars. What you see is what you get. And take what's in the bars, switch the symbol, switch switch a sign. And then, of course, the algebra. Excuse me. So b less than or equal to 9. B greater than or equal to negative 13. Holy cow, that is 22 apart. What do you want to count by? I'm not threes is fine. I'm not a huge 3 counter fan, you know. I like to count by either 2s or 4s or 5s or 10s, you know what I mean, keeping it a little more simple. So I'm going to count by 4s. Bad part is 9's not a multiple of 4 and 13's not a multiple of 4. Are you with me on that? So we're going to make it work though. So negative 13, I'm going to go down to negative 16. Then negative 12, negative 8, negative 4, 0, 4, 8, 12, 16. And what I got to do is go into no man's land and put where this guy's supposed to be. So 9 is definitely between like 8 and 12, but where at, you have to tell me. You have to literally put the number 9 above that. So I know that you put it at 9. It is a closed dot, and we are going less